Any ideas? Divide it. We're just gonna do some long division, right? Remember, it's funny, I taught summer school this summer and we did a lot of this like very basic math that I'm sure you guys haven't thought about for a long time. The number in the denominator is what goes on the outside, and then the number in the numerator goes on the inside. So I'm gonna do 8 divided by 7. Remember, if I can't do 8 doesn't go into 7 any times, 0, so then I'll do 8 into 70. 8 times what is the closest thing to 70? 8 times 8, very good, because 8 times 8 is 64, and then we're gonna subtract those. 70 minus 64 is gonna be 6. We're not done yet, so we gotta keep bringing a 0 down. What's the closest thing? 8 times what gets us closest to 60? 7, good, which is gonna be 56. And again, we're gonna subtract that, which is 4. Okay, let's bring at least one more 0 down. Oh, that's gonna be the trick, right? Because 8 times 5 is going to be 40. One reason I make you do it this way, good morning, okay. One reason I make you do it this way is because we're going to do polynomial division eventually, and so I want to remind you this is what long division looks like. I'm missing one thing though, make sure you've got a negative in front, so I've got negative 0.875. Okay, do you think you can do the next one? All right, I'll do it along with you, but I'm going to be quiet. You try and do it on your own. And then once you get B, go ahead and try C. So my answers for B and C are up there in that box. Everyone feeling okay about that? Not too bad, is it? No. Anybody questions? I'll give you a second to finish that. All right, if we're gonna keep moving it along, now it says graph on a number line. You guys know what number lines, right? You can make that number line look like whatever you want it to. I'll throw -2 right there in the middle. And what is this symbol right here gonna be? Is that a greater than or a less than? Greater than, good. And greater than means bigger, right? Is this gonna be an open or closed circle on -2? Closed, good, why? Because it's or equal to, good, it's got that line underneath. And so I'm gonna go over there to the right, however you wanna do it. If you like a different color, if you just wanna make it a bolder line, that's okay with me. All right, look at the next one, same idea there. 5 is less than X, which is less than or equal to 6. Are my arrows here gonna go towards each other or away from each other? Towards. Why do we know that they're gonna go towards each other? Did you say Brady? They're pointing the same way. Also, it's in between. So I like to think of the way that's written is it's 5, is X is in between that 5 and that 6. So that means it's just gotta be somewhere in between inside of that. Open or close on 5? Open or close on 6? Good. And then we're gonna just shade in between. Those two are pretty cake, right? I'm doing okay. And the only curveball I'm gonna throw for the rest of these is now I'm in a different notation. Do you remember what this is called? Interval notation, good. And I may even make like a little note over here off to the side about interval notation. What do you guys remember about interval notation? What's special about it? Or what do these mean? Like, if I have this like parentheses negative infinity 5 parentheses, what do the parentheses mean? Open, good. So the parentheses, I like to think you can either write open or you can do less than or greater than, because it's not an or equal to, they're open. What indicates that it's closed? Bracket, very good. Bracket means closed. And that's an or equal to or equal to. Do they have to both be parentheses and both be brackets? No, they can be intermixed. Now, what about the numbers? If I have two numbers here, the first number is always what? Smallest, very good, right? It's the smallest number. And that means the second number is always the bigger number, right? The biggest number. The biggest mistake I see is when we throw that infinity wherever we want it to, and it's like, no, if it's negative, that's the smallest value we can have. If it's positive, it's the biggest one. It's got to be in the right space. Now that we have that, this is going to be pretty easy to graph. Am I going to go throw negative infinity here on my number line? No, is there a point that is at negative infinity? No, it's a concept, right? It's just a space. Instead, we'll just throw 5 on. If it says negative infinity to 5, is that going to be a less than or greater than? Less than, good, it's gonna be all the smaller ones. And remind me, is this an open or closed circle on that 5? Open, good. Could I ever have a bracket with my positive or negative infinity? Could I ever have a bracket with my positive or negative infinity? Could I ever have a spot that is positive or negative infinity? No, right? So there's gonna be no bracket ever, so it's always parentheses. Do you think you can try the next 3 on your own? D, E, and F? Graphing those interval notations? I'll put my work on the board, you try them on your own. Hope that's enough. You can see D, E, and F when you've got yours. Check your answers. Okay, how are we doing so far? Everybody doing pretty good? Feeling good about this? Okay, let's keep it moving. Now I've got interval notation and it says write as an inequality. What do I need to write it as an inequality? What are some symbols that I definitely need in order to show this as an inequality? Good, less than's, greater than's. A really important one that we don't have in interval notation is just an X, right? So, and if I have inequality, I need an X and I need one of my greater than or less than or equal to, greater than or equal to ones. So I need those things here. Anyone want to broach this one? Who thinks that they can write 5 or I guess parentheses 5 to 7 bracket as an inequality? It's my first number I'm going to use. 5. We're going to use that small number first again. Small number first. Whenever we write it this way, whenever we have it in this interval notation, we're going to go less than, less than. My question to you is it just less than or equal to or just a less than? So is this parentheses with the 5, is that just a less than or is it less than or equal to? Just less than. Now I'm going to throw that X in there. And then does that bracket make that 7 less than or equal to or just a less than? Less than or equal to. All right, same idea for that next one. Do I need to physically write negative infinity when I do this? I can just worry about the 3, x and 3. Do I want numbers bigger than 3 or smaller than 3? Smaller. And do I want them equal to 3 or not? Yes. So x is less than or equal to 3. All right, and then the last one's just a, oh, I guess there's not a last one on here. I have it on my paper. That's okay. All right, my next 3 are in interval notation. So we're gonna take our inequality and write it into interval notation. You want me to walk through with you on this one, or do you think you have it? You think you got it? You want me to walk? Okay, we'll walk. All right, when I only have one number, it means I need a positive or negative infinity here. X is greater than 6. Is 6 the smallest number, or is it the biggest number? Smallest. So then that means infinity is my biggest number. My greater than sign tells me if it's going to be a parentheses or a bracket. Which one am I going to have here with that 6? Parentheses. And what about with the infinity? Parentheses. Always, always, always parentheses. All right, my next one I think is easy. When I have 2 numbers, those are the 2 numbers I use. Which number goes first? Good. Small goes first, big goes second. Parentheses or bracket with the 5. Parentheses or bracket with the 10. Good. And then last one, x is less than or equal to -7. What am I going to write? Negative infinity. Good. And bracket or parenthesis with the negative infinity. Good. What about with the -7? Bracket. Good. Good. Awesome. All right, we've done a lot of notation. We've done some dividing. We've done some number lines. We're going to get into some properties now. Do you guys remember properties? I feel like we do it like day 1 every year, and then we just like never remember them. I'm going to tell you it's not going to be that big of a deal, but for this P chapter, we got to retain them, okay? So first we're going to talk about distributive property. I think that's one that you guys remember because we use a lot. How do I show distributive property here? Good. Kind of like shoot those arrows in, right? So m times n to the second is just mn squared. And then m times -q is -mq. Does it matter if you write -qm? Is that the same thing as -mq? Ooh, bonus. Does anyone know what that property is? I could just switch those letters. Not reflexive. I heard it commutative. Associative is with parentheses. It's almost the same, but commutative is if I just switch them. All right, let's do the other one. This one, it looks like we need to go backwards. It looks like it was distributed out. And when we go backwards, that's the same thing as a factor. So we're going to factor this out. What's a common factor that's in both of those pieces? Good, 3xy. Any exponents, or is x and y good enough? Good, that's all we can use, right? So when I take 3xy out of 3x squared y, what's left? Good, x minus 2y squared. Awesome. So we can go both ways. We can distribute in or we can factor out. Okay. So I'm actually going to highlight distributive because that is a property that's not listed below. So I'm going to have other properties down here that we're going to have to know the names of and be able to recognize. Distributive is not one that you see down here. All right. Now we just talked about commutative property. Does anyone see an example of commutative property here, Liam?
Is p.1?
B is, yes, B is one. It wants to trick you. B wants to trick you because it's got those parentheses, but the only thing that changed was Y and Z switch and Y and Z switch. So that is commutative. I think I see one more that's also commutative. Anyone else see it? F, very good. Bless you. Another property I heard you guys say a minute ago was associative, and I told you that's the one with the parentheses. Do we have any associative ones out here? H. And then I heard another one. What was the other one? C, very good. So see that you can do a commutative and associative with addition and with multiplication. Okay. The other ones are a little bit funny. Does anyone think that they could tell me what A or D or E or G is? Anyone already know? Zach? One of them is identity. Do we know which one is identity? So let's look at just the two multiplication ones. Is A my identity or is E my identity? A. Good. Why, Brady? It stays the same. Good. So we did something, we did a property, but it stayed the same. Okay, so identity is when it stays the same. And we can even go a step further and say that one's multiplication or multiplicative identity. So I just put like a little mult behind it. Do I have an identity for addition on here where it stayed the same?
D.
D, very good. D stays the same. But that one's an addition or an additive identity. All right, now if you see E and G are the ones that are left, those are going to be the same property as well. Do you remember what we call it when we multiply by something and we get back to 1 or back to 0? We use this a lot with operations. I'll say like addition and subtraction are this kind of operation. What do we call it when it undoes it? You're like, I don't know, Miss White, I haven't thought math in like 10 weeks. Does the word inverse mean anything to you guys? Inverse operations is like if I was adding something, I'm going to subtract it to get rid of it. Inverse operations. When we add things together and we get 0, that's an inverse. And that's your addition, additive inverse. And when you multiply something or divides by something and get 1, that's your multiplicative or multiplication inverse. Okay. So I'm going to tell you on probably on the next quiz and definitely on the test on chapter P, I will have things like this and you'll have to know the identities. Now, is it worth 1,000,000 points? No, but those are like 3 to 5 easy points that you want to get, right? Go ahead and flip that over. We just got a little bit more that we're going to do today. See how it hits P2 right there about halfway down the page? My goal is to get to right this point. Okay. We got a little bit of exponential work to do in here. I know you spent like whole units on this back in Algebra 2, but we are going to practice, see if we remember some properties of exponents. Okay. If I look at letter A, do you remember what I do with this exponent of 3? I'm going to like distribute it in, right? I'm going to give it to everything. So I'm going to start, I'm going to have 3 raised to the 3rd. And then x squared to the 3rd, am I going to add or multiply those exponents? Multiply, very good. So that's going to be x to the 6th. Now, if you're good enough and you already know what 3 to the 3rd is, you don't have to write it down like that. You can go directly to 27 over x to the 6th. But sometimes I get lost and I want to make sure that I have all my pieces. So I did that in between step. I cannot simplify 27 and x over 6 anymore. So that's my best answer. Okay. Let's jump over to letter B. There are kind of 2 directions you can go here. We're going to do the exact same thing. We have to give everything that -2. But before I do that, I could handle that negative. Do you remember what happens with a negative exponent? It flips everything. So even before I give that -2 to everything, I could do this. I could just flip it. I can make it 2y over 5x, and then I can square it that way. Then when I distribute that 2 to everything, I get 4y squared over 25x squared. And as much as you might want to simplify that, you cannot. That's as good as that one gets. Now, if you don't think to do that -2, you could give everything that -2 first. You could do 5 to the -2, x to the -2, 2 to the -2, and then y to the -2. And you'll get to the same answer as I did. I just think that gets really, really messy, so we don't want to do that. Okay, let's do one more together, and then I have you try a couple on your own. All right, here. When I'm multiplying these two fractions together, I'm multiplying these pieces. Let's think about the constants first, the coefficients. 5 and 3, what am I going to do to those? Multiply those, good. So I've got 15 and I've got, that's 6, I'll just keep that on the bottom. Now with my x's, x squared and times x, what am I going to do with that? X to the third, I get to add those together. Same thing on the bottom, x to the third, x to the fourth is going to be x to the 7th, good. And then now we'll do our y's. Y times y to the 5th is y to the 6th. And then y squared times y to the 3rd is y to the 5th, good. Okay, now we're going to have to simplify, okay? Can I simplify anything with 15 and 6? Yep, what can I take out of both of those? A 3, good. So when I take a 3 out, I get 5 and I get 2. Okay, so my new answer is going to be 5 over 2. Now I'm going to think about my x's. I've got x to the 3rd and I've got x to the 7th. What am I going to do with those two exponents? Subtract them, good. So 3 minus 7 is -4. Where does that -4 go? On top or on bottom? On bottom. And that makes it a positive. So if I have a negative and I decide to put it on the bottom, it's got to stay, it's going to go back to positive. All right, and then last I've got y to the 6th, y to the 5th. What's that going to be? Y to the first, is that on top or on bottom? Oh, very good. Okay. You might have gotten halfway through this problem and been like, Miss White, we could have simplified at the beginning and that would have been way easier, right? Did anybody look at the beginning and try and cross cancel? Where you maybe were like, okay, look, I've got an x squared on top and an x to the 4th, so I can cancel that out and I just get x squared down here. Did any of you guys think to do that? You definitely could. However, that wasn't going to let me do our multiplying exponents and dividing exponents practice with you. So you're allowed to cross cancel right from the beginning, but I wanted to go over all the rules with you, okay? You should get the same answer either way. All right, I'm gonna be quiet and I want you yourself, or you can turn and talk to a neighbor. I don't care. I want you to try D and E. And then I'll put those answers on the board. Try D and E. Turn and talk to someone if you want. It's totally fine to talk in this class. Maybe I should do attendance before Mr. Fuji calls. I'm gonna do number D on the board if you want to check in. If you're rocking and rolling, just keep it moving. Right, I've got D on the board if you need to check your work on that. All right, when I jump over to E, I am actually, unlike what we did before, I am actually gonna distribute that -2 to everything. Because I have negatives inside and I don't wanna get confused, I'm gonna distribute it to everything. So this might get messy for a second. Four. Was it 9? Oh, I had 4 meetings. Oh, that says 12. And that says 8. Did you guys get 9?
Yeah.
Okay. Sorry. Okay. All right, everyone feel good about that? A little preview on your homework. Remember, we only have to do the front side. The back side has a bunch of problems like this, where it's all this exponential work. So if this is something hard for you and you want help from me, or you want to do some extra practice on your own, there's a bunch of problems like that for you to get a little bit more work. All right, we just got a couple more problems left to do, okay? Last thing is writing in scientific notation. Am I done in a minute? Or am I done in 10 minutes? 10. Okay, good. I was like, I thought I was really good at my timing, but I got really panicked first. Okay, scientific notation. Do you guys remember how we work on this? We gotta move that decimal. Where do I want that decimal to be here? In between the 4 and the 2. So I'm gonna move it, move it, move it, move it. So it's between the 4 and the 2. Now I'm gonna say times 10. Am I going to have a positive number when I move to the left? Or am I gonna have a negative number? Positive. When I have a really big number and I make it a smaller number, it's gonna be a positive exponent. And how do I know what number that exponent of 10 is gonna be? How many little jumps you did, right? So we did 1, 2, 3, 4 jumps. So it's gonna be 10 to the 4th. A really big number is gonna have a positive exponent. A really small number is gonna have a negative exponent. So that's what I remember. So on this one, I'm gonna move it, move it, move it. 1.6 times 10 to that, and I was a very small number. I moved the decimal to the right, and I moved it 1, 2, 3, 4 places. All right, those are pretty simple. Where it gets a little bit more complicated is when I've got to do a little bit of math with it. But this is why we're talking about it in our exponent area, is because we can break it apart. We can treat these two together, and we can treat these two together. Okay, so we can do 3.6 divided by 1.2. You may need a calculator, but I'm thinking that is 36 divided by 12, and that's the same thing as 3. So it's 3.0. And then times 10. And what am I going to do with 19 and -3? Subtract. 19 minus -3 becomes a positive 22. I did not have to do any more moving with my decimal because my decimal point was already where it was supposed to be. All right, 2 more like this. Now you may want a calculator. I'm not expecting you to know how to multiply these 2 numbers in your head. It looks like I'm gonna get 11.4. Anyone else doing the calculator agree with me? Good. And then times 10, am I gonna add, subtract, multiply those 2 numbers together? Add. 16 or 6 plus 9 is gonna add 15. Am I done here? No, I gotta move that decimal one more spot. And when we move it one spot to the left and make it 1.14, that means I'm going to make my exponent go up 1. It's gonna increase by 1. So it's gonna be 1.14 times 10 to the 16th. Okay, you ready for that last one? Okay, same thing here. You might want your calculator for a little bit of work. For sake of time, and because I know that you can plug into a calculator, that's not a skill that I'm testing you on right now. I'll multiply 1.5 times 8.5, and then I'll divide it by 1.2, and I get 10.625. Same thing as what we were doing before. We're gonna do our exponents. I'm gonna do my numerator first, 13 and -4. We're going to add those together, so that becomes 9. And then I'm going to minus 7 from 9 and get 2. Am I done? One more step, move that decimal. 1.0625 times 10 to the what power? 3. Very good. And then the very, very last thing it wants us to remember, or it wants us to ask is true or false, is -4 squared the same thing as parentheses -4 squared? No. Which one's gonna be my positive 16? The parentheses one. And then the non-parentheses one is negative because it's doing 4 squared and then it has that negative there. So just a quick reminder, those two are not equal to each other. Okay, you guys did so great, and now we've got about 5 or 6 more minutes and you can start on your homework, okay? Remember, it's just that front side. So when I see you on Tuesday, this is gonna be in my hands. So if you have questions on it, you have the next 6 minutes, you have office hours on Monday and probably after school Monday to ask questions about it.
So 10
10 to the 30. Yeah. Anybody have any more questions? Okay. Let me pause this.